Hi guys, welcome back to this channel, and in this video we want to talk about this proof because we've been talking about epsilon definition, epsilon delta these days, and this is another interesting thing to work on, right? This is just a practice question. So I want to show that if f of x can be x squared, come to think of it, the limit of f of x leading to c, of course, if I just do a direct substitution, it should just be c squared, so that's not a problem. So but I want to show it using epsilon delta. That's the main work. So before I can even show it, I need to know what is epsilon delta. So what is epsilon delta definition? It's just for all epsilon greater than 0, okay, there is a delta, right, that is greater than 0, the positive number, right, such that the distance between x and the critical and the limit point is less than that number. And this implies that the absolute value of f of x is less than L. And this is, sorry, minus L is less than epsilon, right? So I want to bring out x minus c from whatever I'm doing. So what is my f of x? My f of x is x squared. So I'll just say x squared minus my L. What's my L? C squared. And this is actually less than epsilon. Knowing fully well that x minus c, that is my limit point, still c, is less than delta, right? And this implies, so I want to bring out x minus c, but I have x squared minus c squared. So I can work in the range by saying this is difference of two squares, x plus c, x minus c, right? That's easy to do. So less than epsilon. And this is actually less than or equal to absolute value of x plus c, absolute value of x minus c, right? This is less than epsilon. So I already know that x minus c is less than delta, so I don't need to stress. But I need to work on x plus c to become x minus c, right? So let me take x. I want to find the neighborhood basically of x between x c minus delta and c plus delta. So let me take c plus 1 as the neighborhood of c. So let's just say that x minus c, let's use another pen for the sake of recalling. So I want to have x minus c is actually less than, let me say, c plus 1. So this means that I will just have minus c plus 1 is less than x minus c less than c plus 1, right? That's just it. So I want to make x minus c to become x plus c. Let me just add 2c to both sides. I'll add 2c here. I'll add 2c here. So I will be having something like this: minus c plus 2c minus 1 less than x plus c less than 3c plus 1, right? So and that's the c minus 1 is less than x plus c is less than 3c plus 1, basically. So now I know that x plus c is less than 3c plus 1. So I can replace what I was doing initially by saying that, okay, oh, this is actually less, basically it is less by 3c plus 1, right? And the absolute value of x minus c is less than epsilon, and x minus c is actually less than delta. So I can bring that to say this is equal to 3c plus 1 delta, right? That's interesting, less than epsilon. So to conclude this one, for us to get the value of my delta, I will just have to write my delta will now be less than epsilon less than 3c plus 1. I can take that whole value of c basically, so it can be positive. So yeah, so to show it in a full working, I will just have to come back here to really be sure. This is epsilon here. I've been able to get that epsilon, that data I'm looking for. So if I should put it in from this place here, checking the proof now, the proof, it will just be that absolute value of x plus c, absolute value of x minus c. Let's see, this is already less than delta, and this x plus c, we know that it is 3c plus 1, right? And what is delta? Delta is actually less than uh, epsilon over 3c plus 1. Of course, 3c plus 1 will cancel 3c plus 1, so we've been able to get less than epsilon, and that's exactly what we want to get. So it shows that this is true. All right, so don't forget to like, share, and subscribe to this channel, and I'll see you in the next video.